will be doing the first chapter of chemistry, chemical equations and reactions. So what is a chemical reaction? Well, so chemical reaction, let us take some examples, maybe you can understand with the examples. So when food gets cooked, this is all taken from NCRT. Okay, when food is cooked, what happens is, if you know, you take salt, you take some vegetables, and you take fire, and you make a delicious dish, right? So that delicious dish is not fire and vegetables and salt and all the other condiments and all, but this is a different thing altogether. So this here is a different thing than what we inputted in. Like, we input vegetables, salt, water and stuff, and we get out deliciously cooked food. So that is, we can say, a chemical change. Or when we breathe, okay, so when we breathe, that too is a chemical reaction, because what happens is the O2 goes in our body, helps converts into ATP, helps all our cells get energy and come out as CO2. Well, oxygen does not become CO2. The waste of the cells which take in the ATP is called CO2. That we learn in this first chapter of biology. But for now, let us see one more example, the last one. When grapes get fermented, when grapes get fermented, they become alcohol. Yeah, they become alcohol. So grapes are very essential in the alcohol industry and all. But now let us see how we can know if a chemical change has taken place. Okay, the one thing could be that there could be a change in the state of there could be change in the state of the chemical equation or reaction or substance. So now, if you know that there's one experiment in which that you take a flask and you take HCl, here this is HCl, and you put zinc in it. Okay, you put zinc in it. This is not the color of zinc, but you put zinc in it, and you can notice that there is H2 gas coming out. This is H2 gas. Okay, so this here was not there when we kept the zinc. This came out as a new substance, or this is gas. It's a different state than what we put. We had liquid and solid, and gas came out. So that could be a change in state. Okay, next could be a change in temperature. Okay, now here in the same experiment, what happens is that this flask, it starts getting a little warm. If you are doing this experiment, you can hold the flask and see it becomes warmer. So a, the change in temperature can also decide the chemical, if a chemical change has taken place or not. The next one is a change, or a change in the color. Okay, so in the change in color, we can say when potassium magnate is added to HCl, the potassium magnate is usually purple in color. Okay, when it's added in HCl, the color becomes colorless. There is, like, it becomes transparent. So that here this is colorless now. So now, what I have here, we can also say that a chemical change has taken place because there was a change in the color. The third thing which we can determine if it has taken place is the evolution of gas. In the same experiment, notice evolution of gas. In the same experiment, this experiment here, we can see that there is evolution of H2 gas, and that this is obviously a chemical reaction. Now here, these are the three things or the four things which determine if a chemical reaction has taken place or not. Now, let us learn how to write chemical equations. Now, let us do, if you remember, this has come in almost every year. Now, there is this magnesium ribbon burning experiment, right? When we burn this magnesium ribbon, there is some things formed which is known as magnesium oxide. Okay, it's called magnesium oxide. So here, what is this? Is the magnesium strip. Okay, this is a magnesium ribbon. Now, this magnesium ribbon is burning in fire, or in, like, fire or getting hot. Now, we don't write that magnesium, like magnesium is with fire, like that. But when we know that some equation is getting burnt, or is getting heat with, with fire, what we usually write is we write oxygen. Okay, it is burning in the presence of oxygen. Now, here again I'll tell you that we do not write plus fire, we write oxygen. And now the product formed is magnesium oxide. So how we can show magnesium oxide is formed is we denote it with an arrow, and then we write magnesium oxide. Okay, now if you remember in ninth standard we learned about the different elements and their symbols, right? Symbols means how to denote them in a shorter way. So magnesium is shown as Mg. Okay, oxygen is O, Mg, and oxygen is O. So and magnesium oxide is MgO. It's actually MgO. um, So oxygen is denoted with O2, okay? That's the mistake. So Mg is denoted, I mean oxygen is denoted with O2, but magnesium oxide is denoted with only a single O and not two. Now here what we got, this thing is way better than writing all this, right? So that's why we usually prefer to write it in smaller or shorter forms. Now, here, notice, if you remember one more thing, this is all about remembering stuff in the previous classes. So, eh, we know that there was one law, that mass cannot be created or destroyed, right? We learned this in our previous class, but notice here I'm having one atom of magnesium and two atoms of oxygen, but in the end I'm only getting one magnesium and one oxygen. So what we do here, we see that there is one Mg and there is one Mg. So the magnesium is equal in both sides. But now if we come to the O2, we have O2, two atoms of oxygen, and here only one is there. So what we do is multiply 2 over here. By multiplying 2 over here, what happens is we get two oxygens and two magnesiums. Now after that, here we only have one magnesium, here two magnesiums are there. So again, if you have guessed it, yes, we will write it another 2 here. Now the final equation which we get is 2Mg plus O2 is 2MgO. This is the balanced equation. The non-balanced equation are usually known as skeletal equations. They are known as skeletal equation. Okay. Okay. Now let us see how we can balance equations in a you know, more more better or more defined way. So now if I say that there is zinc and sulfuric acid Okay, and then we are getting zinc sulfate and hydrogen. Okay, now this is the equation which we want to write in symbols because this is too long, right? So zinc is denoted by Zn, okay, and sulfuric acid is H2SO4. Now, and zinc sulfate, I want you to pause the video and try this out for yourself. Now, zinc sulfate is going to be ZnSO4, and then I'm left with H2, so I'll add H2 here, which is hydrogen. Okay, now let us observe a few things in here. Notice that there is one Zn and we have another one Zn, which is, it's enough on both sides. We have SO4 and another SO4. This is also balanced, and H2 is also same, right? SO4 is in one amount, SO4 is in one amount, Zn is in one, Zn is in one, H2 is in two, and H2 is in two. So by H2 I mean two hydrogen atoms. Okay, now after this we know this equation is already balanced, so we don't need to balance it further. But now if I take an equation Fe plus H2O gives Fe2O Fe3O4 plus H2. Here of course it doesn't look balanced because there are way more numbers over here than there, right? So now what do we do here is we write a table. So the table is going to be, we have to write the element in the beginning, okay, and then we write number of atoms in reactant. So again I want to tell one more thing which I forgot. This is the reactant side and this is the product side. Okay, usually they are usually known as LHS and RHS because it's on the right hand side and that's on the left hand side. Okay, number of atoms in LHS and number of atoms, okay, number of atoms in RHS. Okay, now the element we have here is Fe. So we write Fe. There's hydrogen. Fe is iron. Okay, we have hydrogen H and O. Now let us notice on our right hand side, this is the left hand side, and this here is the right hand side. Okay, number of atoms in the left hand side. Now here notice we have Fe as 1, so it's one atom of iron. Here there are 3 atoms of iron, so 3, and hydrogen is 2 and hydrogen is 2, that's balanced. And we have one oxygen. Oh, and this is 4 oxygen here, so we have 1 oxygen here and 4 oxygens there. This definitely does not look balanced. If we want it to be balanced, what needs to happen is that these two numbers should be same. Here it's not. So how we can do that? First let us notice there are 3 in the RHS, so we write 3 here. Just simply write 3. Right now we have 3 Fe, so this becomes 3. Next, notice H is already balanced. We don't need to work too much on that. O, again, we have 1 oxygen and 4 oxygens. So 4 oxygens, we need 4 oxygens, so we write a 4 in front of here. Now the problem is we get 8. We get 8 in the LHS side 8 hydrogens in LHS side, while our oxygens are, it's balanced. Now again we have a problem with the hydrogens on the RHS. Now in the RHS, what we do is we have 2, and we know 2 times 4 is 8, so we write 4 over here. So and then again 4 2s are 8, so we get 8 atoms of hydrogen in the right hand side as well. Now we have equal atoms in the RHS and LHS, and similarly here and here as well. So this, now all three are same. So this equation which we have here, this is now balanced. So the final equation which we get is 3Fe plus 4H2O, okay, plus 4H2O gives Fe3O4 plus 4H2O, I mean 4H2.